Welcome back to Comp 2160 Programming Practices. It's me, Franklin. I hope that you're doing okay today on this Friday. We are at the end of week 5. We are very rapidly approaching the end of the course. And as with the last 4 weeks, what I want to do here is just very quickly take a look at the learning outcomes that we covered this week and give you an idea of what you might expect to be assessed on in terms of those. So let's take a look. Here are the learning outcomes from this week. The main things to notice here are that one, we have nothing due this week. Hooray! Yes, that's great. We don't have anything due this week. There's no tests. The final assignment is due at the end of next week, as noted here on the course syllabus. Although, of course, you should check out the assignment document to see what the due date is and look very closely at that due date. By the end of this week, students should be able to describe the benefits of modularity and use simple metrics to specify the degree of modular independence, such as coupling and cohesion. And the other one is divide code from a complex project into higher level modules for separate compilation and development. These learning outcomes, this one specifically, describe the benefits of modularity and use simple metrics to specify the degree of modular independence. You can expect to see a question kind of related to this on the final exam. I showed you some really abstract pictures in class and then asked you to try and measure the coupling and cohesion for each of these. So remember, we're thinking about high or low cohesion and high or tight coupling and low or loose coupling. This upcoming week in class, I'm going to show you some examples of code, and I'm going to ask you the same question. In terms of what you might see on a final exam, you might see code and be expected to answer the same kind of questions. So whether it has high or low coupling, whether it has high or low cohesion, but then also being able to explain why that's the case. So it's not enough to just say that this has high coupling, but you have to explain why this thing has high coupling or why these two things have high coupling when they're connected to each other. Divide code from a complex project into higher level modules for separate compilation and development. We've been actually kind of doing this for quite a while. We really just didn't formally talk about it until this point in the course. So when you were working on, for example, assignment 2, we had already divided our code up into several different pieces where you were required to implement a stack abstract data type. And then you were supposed to recompile all those pieces together again. So divide code from a complex project into higher level modules, we already started to do that. And you've been assessed on that a little bit in terms of code already with assignment 2, or you will be receiving an assessment about that. In this one, another way that you can expect to be assessed is going to be, here is maybe a header file that has or describes some kind of complex project. How might you divide this into different modules? What kind of ideas are in here and what different parts would you separate this out into? The other two learning outcomes that we've got for this week are describe concepts of in-application memory management, such as first fit memory allocation, the runtime stack, and the heap and garbage collection. So we talked about the first fit memory allocation policy in class extensively related to assignment 3. We talked about the heap a little bit more in class. So we were thinking about things like the lifetime of values that are being allocated in the heap compared to those that are being allocated on the runtime stack. You were already assessed on the runtime stack on the term test, so you may have some sense of what you could see about the runtime stack on the final exam. But in terms of what we were looking at this week, I'd expect you to be able to basically do the first fit memory allocation policy on a piece of paper, given some description of the state of memory at some point. I'd expect you to be able to describe, again, at least at a very high level, where the stack is located physically in an address space for a process. So remember, we got code, heap, and then stack at the very bottom of the address space for a process. You're also going to be assessed on this in terms of implementing this code in an assignment. And that's in assignment 3. So that's something that you're working on right now. But in terms of a final exam, you might expect to see, do first fit memory allocation in written form, given some memory constraints and some request for a resource. For performance, the last learning outcome that we've got here, we only started to work on this week, so we're going to continue to take a look at this next week. But the learning outcome here is, given an existing solution, identify and explain where the use of appropriate data structures, algorithms, and or techniques such as caching and lookup tables provide better paths to optimization than low-level code. The place that we got to this week is really just that, just identify. And so what we were looking at yesterday in class was the use of profilers to be able to tell us and give us hints about where to look in terms of what part of our code is causing this whole thing to be slow. We're eventually going to look then at some actual bigger code examples and begin to think about how using appropriate data structures. So remember, we've got these abstract data types, and then we've got data structures. And what we've seen so far is that we've got a couple of different abstract data types, so a stack and a string, and now also a zone, a memory zone. And the data structure that we could have been using for all three of those is a list. Algorithms and or techniques in general, so caching and lookup tables, provide better paths to optimization than low-level code. We're going to look at some examples of using low-level code, but the result that we're going to find with this next week is that it's kind of like diminishing returns. You'll get a little bit of performance out of low-level code, but you're going to get a lot of performance out of changing the data structure that you're using or changing the algorithm that you're using. So that's it for the learning outcomes for this week. I hope that you have a great weekend, and I am looking forward to next week, where I think that we're going to do some really cool stuff. One thing that I like to do to kind of end this course off is to give you a little introduction to doing C development on the Game Boy Advance. That's a class that it's kind of like it's not going to be covered on the final exam, because they don't expect you to have a Game Boy Advance on the final exam, but I think it's kind of fun to try something a little bit different. So I hope you have a great weekend, and I will see you next week. Bye, everyone.